Good evening. Tonight we're going to start with Lesson 9 in Module 3. I can multiply 3 and 4 digit numbers by 1-digit numbers applying the standard algorithm. Alright, so tonight, guys, we're going to get away from the place value chart, working our way in with the partial product method, and then finally getting in and applying it to the standard algorithm of multiplication. So let's get started. Alright, well, we'll try this, and just to get ourselves started, we'll go back to that place value chart. And 162 times that by 6. So let's set that up. We have 1 in the hundreds. We have 6 in the tens. And we have 2 in the ones. But we have 6 groups of that because we're multiplying by 6. So we've had 1 already. 2, 3, 4, 5, 6. And then we have 6 tens, but we're grouping that with, we get 6 groups of that. So we've got 1, 2, 3, 4, 5. See, it's 6. That's 2 groups. That's 3 groups. Oops, why is that not going? 1, 2, 3, 4 groups. 5 groups. 6 groups. And that's a lot of tens in there. And then we go to the ones, and we've got 2 in the ones, but we need 6 groups of that. So we already have 1. That's 2. That's 3. That's 4. That's 5. And that's 6. All right. So now we need to group up those tens. Okay, so let's see if we can get 10 ones. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can group, we can group this 10 ones and cash it in for 1 10. So now we are left with 2 ones. Now the tens, we've got a lot going on there. So let's group 10 tens to make 100. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop, and let's group this 10. And we are now cashing that in for 100. 10 tens equals 100. Let's see if we can get another one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have another one here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, that's 6, 7, 8, 9, 10. Sorry. Dots are too small. And this right here becomes another 10. And then let's see if we can get another one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's another 10 right here. So let's, even the one that I accidentally circled becomes, and there's another 10. How many are we left with? We're left with 1, 2, 3, 4, 5, 6, 7. 7 tens. How many hundreds do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Not enough to make 1,000. So we have 9 hundredths. So let's see if we can get this in our partial product view. We have 2 times 6. 2 times 6 is 12. That is 2 ones times 6 ones. And that is 6 times 2. So the next one is 60 times 6. And 60 times 6 is 360, and that's 60 times 6. Now remember, this is not just a 6. That's in the tens place. That 6 is in the tens place, so it's 60. We got to get used to knowing that when we want to do our standard algorithm. And it also helps us in our partial product, too. And then the next one is, that's not just a 1, that's 100. So 100 times 6 is 600. And now we need to add up our partial products. 2, 972, just like we have in our partial product. The next one we are now going to do in the standard algorithm way. And just like I did in this one, we used the place value chart, and we had to group, and we had to bring over the group, bundled up the ones, and we made a 10, and then we bundled up the tens to make a hundreds. We're not going to use the place value chart for this one. I'm going to show you how to just do this the standard algorithm way. Now, just like I said in the previous slide, this is a 1 and this is a 1. So 2 times 6 is 12. But in our partial product way, we would put the 12 right down right away. But we're not going to do that. We need to carry the 1 over into the tens. Again, this is not a 6, that's a 60. So it becomes 60 times 6. And that is 3. That's 300. I'm sorry, it's 36. So that's 360 plus the 1. Okay, so 6 times 6 is 36 plus the 1 is 37. We put the 7 and we need to carry the 3. And we have 1 times 6. Again, that's 100 times 6. 1 times 6 plus the 3 would be 9. So it's 972. So just like what we showed back over on this previous slide, we regrouped and we bundled up the 1s to make a 10, and then we bundled up the 10 tens to make 100. And just like in our partial product method way, we did not have to show all those steps. We just carried over our 1 and our 3. All right, now let's try this one. We're going to do the partial product algorithm, and then we're going to do the standard. So, how do these look? Well, we have 7 1s and 5 1s. And 7 1s times 5 1s is 35 1s. Then we're going to go to the 3 here. But that's not a 3. That is really 3 10s, which makes it 30. So this becomes 30 times 5 is 150. Then we're going to go to the next place. This is not a 2. That's a 2 in the hundreds, so it becomes 200 times 5 is 1,000. So now what do we do with partial products? We have to add them. So it becomes a 5, an 8, and a 1, and a 1. So 1,185. This is our partial product algorithm. Now this is going to be our standard, and this is how it looks different, like I showed you in the previous slide. 7 times 5 is 35. We have to put the 5 and then carry the 3 into the tens. 3 times 5 is 15, plus the 3 is 18. So we need to put the 8 and carry the 1 into the hundreds. 2 times 5 is 10, plus 1 is 11. So it becomes 1,185. And see, our products are the same. Shane measured 357 milliliters of water in a beaker. Olga measured 3 times as much. How much water did they measure all together? Well, here is Shane, 457. This is Shane. And Olga measured 3 times as much. So this we want to know all together. And how we do that is that we're going to multiply 3 times. So 457 times 3. And we're going to do this by getting closer to that standard algorithm. So I'm going to show the standard algorithm and not the partial product way. So 7 times 3 is 21. We put the 1 down and we carry the 2 into the tens. 5 times 3 is 15 plus 2 is 17. Put the 7 down and carry the 1 into the hundreds. 4 times 3 is 12 plus 1 is 13. So it's 1,371 milliliters. All right, we're going to try to solve each one of these using the partial and then comparing it with the standard. So 34 times 4, and we're going to be using the partial product way. So 4 times 4, 16. But now this is not a 3, this is a 30. So 30 times 4 is 120. And what do we do with partial products? We add them. 6 ones, 3 tens, and 100. 136. Now we're going to go to the standard algorithm way. That's when we're going to have to show, keep bringing our numbers over. 4 times 4, we said was 16, put the 6, carry the 1. 3 times 4 is 12, plus the 1 is 13. And there we go. Our two products are the same. Partial product way again. 224 times 3. And so the ones is 4 times 3, and that's a 12. We now go to the tens. This is not a 2, that's a 20. 20 times 3 is 60. And the 2 in the hundreds is not a 2, it's 200, because there's 2 in the hundred, so it's 200. 200 times 3 is 600. And what do we do with partial products? We add them. And we get a 2 in the ones, a 7 in the tens, and a 6 in the hundreds. Now we're going to go to the standard. 4 times 3, we put a 2, carry the 1 in the tens. 2 times 3 is 6, plus the 1 is a 7. And 2 times 3 is 6. We have 672, and our products match. All right, let's give it one last try, and we're going to practice going back to that standard algorithm, because that's our goal, to get used to that. So we have 1 times 3, 1 in the ones column, and 3 in the 3 column. So 1 times 3 is 3. 5 times 3 is 15. You put the 5 and you carry the 1. 2 times 3 is 6, plus the 1 is 753. All right, guys, I'd like you to give it a try. 392 times 6. Try the standard way. All right, try number 3. The product of 7 and 86 is, try using the standard algorithm. Next one, try 9 times as many as 457 is, try answering number 4, standard algorithm. And number 5, Jason wants to make 5 airplane propellers. He needs 18 centimeters of wood for each propeller. How many centimeters of wood will he use? Try using the standard algorithm. Number 6, one game cost $238. How much will 4 games cost? And our last problem for this evening, number 7. A small bag of chips weighs 48 grams. A large bag of chips weighs 3 times as much as the small bag. How much will 7 large bags of chips weigh? Awesome job tonight, guys. We'll work more with this tomorrow. Have a wonderful night.